How does a battery work? Well, it's surprisingly simple. They use a chemical reaction between the battery acid and two different metals to make one side have too many electrons, the negative side, and one side have too few, the positive side. Wait, how does that make a battery in current? Well, I'll tell you, and along the way, I'll tell you why some materials conduct electricity and some don't, what current actually is, how every science teacher and electrician in the world is lying, and the importance of meeting of free electrons and ions. Don't worry, it's actually surprisingly logical for chemistry. Ready? Let's go.
Electricity, 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 electricity.
Let's start with the basics. All objects are filled with a ridiculous number of tiny negatively charged electrons and comparatively huge positively charged protons, and a whole bunch of neutral neutrons that are unimportant here. For example, this piece of metal has about 2 million billion electrons and protons in it. The protons, electrons, and neutrons form atoms. The protons are stuck with other protons in the nucleus, with the heavy neutral neutrons that act like glue. The only thing that distinguishes different elements is how many protons it has in its nucleus. For example, gold has 79 protons, lead has 82, and lithium has 3. In theory, you could split a pile of lead into equal amounts of gold and lithium. However, nuclear fission is very difficult to do, and we tend to only accomplish it with big elements like uranium and radium. Plus, nuclear fission is dangerous. Anyway, most of the electrons are stuck or bonded to the nucleus. If the atom has the same number of protons as electrons, then it's a neutral atom. If that was the whole story, then we would have no current or electricity. However, sometimes an electron will escape the pull of the nucleus and basically roam free. This is called a free electron. Good name, huh? When the electron escapes, the atom is left with one more positive proton than negative electron, so it has a positive charge and is called a positive ion. To recap, objects are made of heavy neutral atoms, negative tiny free electrons, and heavy positive ions, atoms that have lost an electron or two. Current is made of flowing electrons. That is all current is. Now, the individual electrons do not move very far, but they basically set up a wave of electrons moving generally in the same direction. Metals have a lot of free electrons and ions, so electrons can flow easily through them, and they are called conductors. Plastics have very few free electrons and ions, so electrons cannot easily flow through them, and they are called insulators. That's why a wire is made of metal for the current to flow through, with a plastic insulation to keep the current from flowing out of the wire into, say, your hand. So how do you get the electrons to move in a metal? One way is to use a battery. Look at a battery. It always has a positive side and a negative side. The negative side has too many electrons and the positive side has too few. Opposites attract and like repel. So the negative electrons want to get away from the negative side and are attracted to the positive side. If you connect the sides with a conducting wire, the electrons flow through the metal and into the positive side. Side note, you might have been told the current flows from positive to negative. That is because Ben Franklin made up those names and ideas 150 years before the discovery of the electron. We say current flows one way, when what is really going on is the electrons are flowing the other way. In other words, every science teacher and electrician in the world is lying. Crazy, right? Okay, but I still haven't told you how the battery works. How does a battery create and maintain a positive and negative side? Well, every battery uses the interaction between two types of metal and an acid or a base. Acids have chemical reactions to move the free electrons, and bases have chemical reactions to move the positive ions. But either way, they leave the positive side with too few electrons and the negative side with too many. The original battery in 1800 was just strips of silver and zinc and a cup full of salt water as the acid. This made a very weak battery, but the salt water would react with the zinc to add electrons and react with the silver to remove electrons. For the next 99 years, all batteries used acids. However, they are inconvenient, as the strong acids tend to eat away at the container of the battery, and as they were liquids, they were easy to spill. In 1899, we started using bases instead of acids as a chemical, although we still use acid in the lead-acid car battery. For that reason, many batteries are called alkaline batteries, because another word for base is alkaline. chemists always have multiple names for the same thing. Drives me nuts.
Anyway, there are many types of batteries used today, but let's look at a typical alkaline battery. Alkaline batteries come in many shapes and sizes, but inside, they all tend to have the same metals and chemical reactions. So let's look at what's going on inside one of these batteries. Inside an alkaline battery, there's a column of ground zinc mixed with the base chemical potassium hydroxide. Surrounding the zinc is a hollow cylinder of a different metal called manganese oxide. The chemical potassium hydroxide reacts to the zinc and removes positive ions, leaving that side with too many free electrons. The chemical also reacts to the manganese and adds ions, leaving that side with too few free electrons. The zinc and the manganese are separated by a plastic sheet, so the electrons don't just move over to the positive side with the ions. Therefore, the electrons in the zinc side are stuck there. They move as far away as they can from each other and congregate on a nail, called a current pickup. This reaction occurs until the charges on both sides create such a strong electromotive force that the chemical reaction stops occurring. In a typical AA battery, that is 1.5 volts. When the battery is placed in the circuit, where the electrons can flow in a conductor to the positive side of the battery, the chemical reactions occur again to keep the electromotive force at 1.5 volts. When the chemicals in the base react to the metals, the chemical becomes less powerful. Over time, the chemical loses its power of reaction, and the zinc runs out of ions to move, at which point the battery is dead. Alkaline batteries are not rechargeable batteries. However, rechargeable batteries work the same way as disposable batteries, in that a chemical moves over ions or electrons, so the positive side has too few electrons and the negative side has too many. However, rechargeable batteries reverse the chemical reaction when the current is forced through them in the opposite way, so that the ions move back to their original metal and the chemical base or acid becomes stronger again.
Different batteries use different metals and different chemicals and different geometries, but they all use either a base or an acid and two types of metal or metal compounds to make the negative side have too many electrons and the positive side have too few. And that's how a battery works.
Electricity, 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 electricity.
If you haven't seen the video of how the first battery was discovered, you should check it out. It's a fantastic and strange story involving jealousy and dead frogs. Either way, join my YouTube channel, Kathy Loves Physics, or my Facebook page called Kathy Loves Physics, or my website, www.kathylovesphysics.com. Have a good day.